So far, for all of our confidence intervals, we've been using that z-score that was associated with the confidence level that we wanted. And in the calculator, we used the z-interval. But we can't always use the z-score associated with the population because we don't always know the standard deviation of our population. And the standard deviation of our sample isn't always good enough. So we do have another alternative that we need to look at, and that's the t-distribution. Mathematically, it is way too complicated for us to even do, and you'll see when we use the calculator, calculator has a tough time with it also. But in general, this is the rule you want to follow. If you know the standard deviation of the population, then you're okay to use the z-distribution that we've been using. If our sample size is large enough, then you're okay to use the z-distribution. But if you don't know sigma, if you don't know the standard deviation of the population, and your sample isn't big enough, you need to use the t-distribution. So let's look at a couple of these. In the situation of IQs, we had a sample of 10, which is very small, so we're in danger of needing to use the t-distribution. But we happen to know the standard deviation for the population of IQs. We know that's 15. We've been doing it all semester. So we can use the z-distribution for this. What we wouldn't do is use the standard deviation of our sample. We would instead use sigma of 15 to calculate our interval. So we would use the z-distribution for this. We'd use z-interval with n of 10, x bar of 102, sigma of 15, and 95% confidence. With the commutes, we had 100 in our sample. That's bigger than 30. If the sample's bigger than 30, we're okay to use the z-distribution. So we did that one correctly too. For the heights of the trees in the last episode, we had 100 trees, bigger than 30, good to go with the z-distribution. The last example though, the footlongs, I want to look at what happens when we do have a sample of 30, an x bar, and the standard deviation. So let's go ahead and put these numbers in here using the z-distribution. So we'll go to stats, over to test, down to z-interval. And the numbers there were what? We had a sigma of 0.15. We had an x bar of 11.9. We had an n of, let's go with 30, and a confidence level of 0.99. Okay, so if we use our z-distribution, we get 11.829, okay, roughly 11.3 to 11.9. I'm sorry, 11.83 to 11.97. So that's using z. Gave us that for our interval. Let's look at what happened if we use the t-interval for this. We'll notice a couple things. Go to stat, over to test. Z-interval should be followed immediately by t-interval. So option number 8. We're asked for exactly the same information. Our x bar is 11.9. Our standard deviation is 0.15. Notice this time it's x instead of sigma because it's the standard deviation for the sample, not for the population. We've got our n of 30 and our confidence level of 99, and I like that the TI keeps the old information in there. Look how long it's taking to calculate this time. Mathematically, finding that z value is very easy, but finding the t value is very, very difficult, so the calculator takes a long time. Now, check out what we get here. We get 11.825 instead of 11.3, and 11.975 instead of 11.97. Very little difference because we have at least 30 in our sample. Now I want to go through and change that. What if I change that sample size to 10? Let's run the numbers for z. Go to z-interval. And we've still got our 0.15. We still got our 11.9. This time we're changing n to 10. That's the only change we're making. So we can calculate that. And we get 11.8 to 12, basically 12.02. So 11.8 to 12. Let's do that again with the t interval. (11.9), standard deviation of 15, sample size of 10, and confidence level of 99. Taking a long time. And now we get 11.75 and 12.05. That's not a huge difference, but when we're talking about statistics and you're using them in medicine or in court, those little differences can make a big difference. So that's why we have the t distribution, because when we have a small sample, that standard deviation is not a reliable predictor of the population standard deviation. Nothing to practice here, just you need to know that distinction. Again, if you know sigma, I erased it. If you know the population standard deviation, you're good to go with the z-test. If your sample's at least 30, you're good to go with the z-test. Otherwise, you need to use the t-test. Next time.